IVM.
Hi everybody, just wanted to ask everyone for a quick favor. We're running a brand survey right now and would really appreciate it if you could let us know what you think about the advertising on IVM. Go to ivmpodcast.com/survey and do let us know. As part of this, we'll be selecting 10 random participants and sending them some IVM swag, so do fill out those surveys.
Hello and welcome to episode 225 of Simplified, which is 15 square. Wow. That's all the bit of trivia that I have. It's a nice, pleasing number. We are going to talk about the wide, happy world of engineering today. And I just thought 15 square brings me back to my
15 square is actually the number of squares in a crossword grid. So.
Oh, really?
Wow. Oh. Yeah, 15 by 15. So, there you go.
There you go. Did not know that. 225 for the win. Okay. We're going to talk about... we are doing this because our producer Vinay said that September 15th is Engineers Day. Indeed, it is Engineers Day in India, at least. It seems every country has, for some reason, their own different engineering day, engineers days. I'm not quite sure why that is. Like local engineers celebrated differently, or maybe the profession of engineering came up differently in different countries. Not quite sure about that, but we are going to speak with respect to the only country that matters, of course, which is India. And we will also use this opportunity. So for 224 episodes, I have wanted to ask Naren what he actually does, because there are some reports that Naren leads a drug cartel, which I don't completely believe in, because I think I think those skills would be wasted in peddling coke across the border, because I have tasted Naren's sauces and he stands to make a better fortune from those. There are other reports that say that he is actually Himanshu Joshi of Indian Ocean. And indeed, I went to an Indian Ocean concert with Naren once. And before the band started, Naren went off. And after the band stopped, he came back. So I have a sneaky suspicion that Naren and Himanshu Joshi have never been seen in the same room. So, but Naren claims that he runs a factory that makes auto components somewhere in northern Mumbai, or the suburbs of Mumbai. So we thought we'd take this opportunity to grill him about all those. But before that, so we need to start with the profundity for this. And since we are celebrating Engineers Day, I actually took a chance and I Googled or Google imaged engineer good morning message. And the same, and I tell you the same quote or the same, message comes up thrice in the top 5. So obviously we have to do this. Okay, so this has a picture of a railway track, and stop me if you've heard this one before. I'm guessing you haven't. When a train goes through a tunnel and it gets dark, you don't throw away the ticket and jump off. You sit still and trust the engineer. Good morning.
Wow.
I am not sure what the reason for this is.
Is this like a quote about engineers or about like generally God and stuff?
I have not. Yeah, so that's the thing, right? So the first version of this has just this much. And subsequent version of this has the addendum that you envisage, which is you still sit still and trust the engineer. Trust God no matter how dark your situation. God says you are coming out. Good morning. So in a way, they are equating engineers to God, which might be a bit of a leap to take, I think.
In my experience, a lot of engineers do think they are God. Yeah.
So at least right now in Bangalore recruitment circles, they definitely don't consider themselves God. I can't find, strangely enough, any others, although there is this little bit of a gem. To the optimist, the glass is half full. To the pessimist, the glass is half empty. To the engineer, the glass is twice as big as it needs to be. This is that's actually not too bad. So I'll actually put in a couple of my favorite engineering college anecdotes, and a lot of this is obviously every college has their own legend, right? Oh, this senior said this during that Viva and he got full and stuff like that. I'm guessing you guys have these episodes. By the way, for those who don't know, all three over here, and Srikeit is not here today because he has a medical emergency. Please message Srikeit and tell him that Please wish him all the happy recovery and all that is fine. He's just gone for something small. All three of us are
Is there
engineers.
such a thing as a engineering emergency?
I guess there is.
I mean, a
there
broken bridge is basically an engineering
Yeah,
but
emergency. Isn't it?
then it's not an emergency, right? You like basically
That is
created the disaster.
Yeah, fair. So, myself, Deepak, I am chemical engineer from 2006 batch Government Engineering College. Thrissur.
Yeah.
You two gentlemen have much higher pedigree. No, please, yes, let's shame ourselves.
Yeah. Tony.
I don't know, where are you guys from?
I am a 2008 metallurgical and materials engineer from NIT Warangal.
Yeah.
And this is actually still immortalized in my Gmail account because that's the time when Gmail actually came to be. So.
Yeah.
And I am myself, Narendra Shenoy. I passed my engineering in 1986 from Manipal Institute of Technology in mechanical engineering. And
Good
both
heavens,
these guys were probably not born. Are either of you born in 86?
Yeah, I was 2 years old.
Not me.
Wow. Okay. It's fun to put things in perspective that way sometimes. But that's nice. Oh, you were in college when India won the World Cup. That must have been interesting.
We watched it. And on.
Oh, wow.
So there were like 2 television sets in the entire town, which...
in the entire town?
One of them... some of us had access to one of them. But basically, there were like a couple of 100 people watching through the windows and things like that. And
amazing.
I was in engineering college when India won the first 2020 World Cup. We actually screened it in the auditorium. Same here, except I was in a B school at that time. I was thinking, what? For me, the major sporting event in engineering college, I think, was the World Cup that happened 2006. As with a Kerala hostel, as you can imagine, loyalties were very, very fractiously split between Argentina and Brazil. And then you had this new crop of hipsters who liked England for some reason because of the EPL had just come up in India at that point of time. So that was fun. I mean, you had the hostel rooms with all the Pele fans on one side, Maradona fans on the other side, all good fun. So with respect to engineering itself, I have some fun. There is some, and some of this might be very specific to engineers. You guys know what a cooling tower is, right?
Yeah.
I mean, Naren obviously knows. Tony, since you're a metallurgical engineer, you will also know what a cooling tower is. Basically, it has to cool water in an industrial process. And one of the standard engineering questions that we are asked during exams, I forget which subject exactly, probably heat and mass transfer or something, is design of a cooling tower. Basically, what material to use, what height, etc. They'll give you a problem that says input temperature is this much, output temperature is this much. Typically, input will be 30, output will be 20 or 15 or something. Hence, it needs to be cooled down. It needs to be done in this much amount of time. This much is the amount of water that passes through. Now design the tower, which basically means you need to use some simple calculation. Say it needs to be of this height, of this radius and whatever. There was a printing error in one of the exams that we got. So input temperature was 20 degrees and output temperature was 20 degrees. Okay, so obviously, like in a situation where there is a printing error in the printing error, all you need to do is just mention all you need to do is just simply attempt the question and you will get full marks because the mistake is not at your end. One smart aleck actually went and did the entire calculations properly, like meticulously. Ti equal to 20, To equal to 20, delta T equal to Ti minus To equal to 20 minus 20 equal to 0. Therefore, height of the tower equal to 0 centimeters. Radius equal to, so he did this entire calculation. And I thought that was absolutely amazing. But my favorite by far, and again, this is something that's super engineering based, but those of you who are engineers will absolutely love this. Transformers, you typically use copper as the windings, right? So there was this is not a question that was asked by a professor because it actually doesn't happen, but somebody asked, what is the main advantage of using aluminium instead of copper in the windings of a transformer? And I remember somebody asking this and in the hostel, and everybody like wondering what possible benefits could there be of using aluminium instead of copper? And we tried to find actual solution. Is this higher? Is this higher? He said, no. Copper loss will be 0. So yeah, engineering is full of stupid little jokes like that, which makes idiots like us.
They're all
So,
engineering
happy Engineers Day.
aluminium. Alumni. Okay.
Okay.
Yes. So engineers,
I mean,
so few engineers continue to be engineers from my batch, and also.
Yeah, I wanted to ask you that, Naren.
Yeah.
How many of you are?
So,
I'm guessing you are an outlier, mostly also because you did an MBA after that.
Yeah. So actually, my thing was I did an MBA, and then I went to work for a large corporate company, and for 3 years, I basically sat on a chair and read newspapers and sort of listened to other people's stock market tips and things like that. And I was, how old was I? I was 23 or 24 or something at that time. I was very restless. And
you just described some people's dream job, by the way.
No, it was really frustrating, and that gave me a lifelong. First of all, that entire MBA experience was stupid because at least back in our time, it was always post facto. It always sounded like post facto rationalization to me. So you'll have some case study and. There'll be some this thing.
Mr. Mehta.
Mr. Gupta was worried. It'll always start with Mr. Gupta.
Mr. Gupta was worried.
Completely random. And all these were culled from Harvard Business Review, and all whatever Jack White or whatever turned to Mr. Gupta, and then everything else would remain the same. Okay. And it was ridiculous. And, it was, all the case studies. So there will be one central point to the case study, and all the facts would be arranged so that it was Captain Obvious at its best. It was intellectually insulting, the entire MBA experience. The only subject which really had any dum was statistics, but they unfortunately had just one paper in it. That's it. On one semester, and all of statistics was done. That's it.
Let us not trash MBA during this specific episode, because I think that's a completely different episode.
We should.
Is there a MBA day? Day for MBA. We should institute this as the simplified holiday.
We should totally have it. Yeah.
No, please let us not do that. Let us not associate. Let's see. I'm actually searching for, is there an MBA day? Thankfully, it does not seem to. Thankfully, this does not exist. So, if anyone wants, please institute it, and we can all celebrate with a PPT. So, Naren, so what did you do after being frustrated, asking to?
So then, I met up with an old friend accidentally, and he was already in the manufacturing space. And he was working with his dad, and that was a very, very small outfit. So we got talking, and he was my school friend. So we decided to start something. And then, then I got into manufacturing. It was great fun. So money wise, I don't think it was that great, because later all my MBA buddies became captains of industry, right? So I'm the only guy who's not a captain of industry. So money-wise, everyone did very well in MBA. But work-wise, I think I had a lot of fun. Maybe not the greatest fun that everyone had, but it's fun. It's you're always creating things. You're responsible thing. When you're running an engineering, at least a manufacturing outfit, and you produce things, those things have to work. Okay, there are no excuses.
Yeah.
So MBA, that doesn't need to be so, right? So you can have brilliant MBAs like Marissa Mayer, who can really organize corporation. Yeah, and you can run the entire corporation into the ground and take a 50 billion or 50 million whatever severance package and then go away. So. In engineering,
in MBA, failure is a LinkedIn post or like a TED talk.
Well put.
Engineering, you can't do that. You have to, if it doesn't work, you're out of business, or you're going to get sued, or something is going to happen. So engineers tend to be very specific. So that's one reference. On the other hand, engineers also tend to be like very, very tubular in vision, right? So they can only they approach everything. Like for me, everything is a manufacturing problem. I really don't think there are any problems in the world which are not connected with manufacturing. And this is why engineers are completely useless in doing anything in
If you only have a hammer, everything looks like a nail.
Yeah, absolutely.
Wow. I mean, I knew the quote, but that's a nice, way in which you put it. When you are a lathe, everything looks like a potential screw, I suppose. So, Naren, what is it that you actually do for the benefit of our listeners, to whatever degree you can tell us without giving away corporate secrets?
Yeah, so we make automobile components.
You should also clarify what you mean by we.
Company, the company that I own and run. And the automobile is a very sophisticated piece of equipment, device.
Machine that moves you.
Yeah.
By
for
burning
a few lakhs, for like 3 lakhs, 4 lakhs. I don't know what the entry-level automobiles are.
Yeah.
And they work, they have air conditioning, they have all kinds of electronic
radio
systems, they have sound, they have, everything works,
chairs.
and you can use those for hundreds and thousands of kilometers without risk to life or limb. Okay. And when you consider that a phone which practically goes kaput within a couple of years costs 70,000 rupees, it's quite an achievement. And that is because it is the engineering in every aspect of it has evolved. So even the components that we make have evolved over a period of time. It's two ways. So when an automobile is designed, they start out with the outer shell and the wheels and everything like that, and then they design all the other sub-assemblies that fit into it, like the engine, the transmission, the doors and windows, and the air conditioning system, the electricals, the seating, everything. And they farm it out. So the automobile company is not an expert at everything. Yeah. So it farms out. So it gives the seating system to a seating specialist. It gives the engine to an engine specialist, and so on. And when all that comes back, it goes on to an assembly line, which is the innovation, which is one of the great innovations that made automotive engineering possible. It was, I don't think it was invented by Henry Ford, but he was a guy who really
took advantage of it, scaled it up, and all that.
He really adopted it.
Yeah. That's interesting. Like only recently, I found out that all these, car companies, they aren't manufacturers. They're just they are what is called OEMs. Original equipment manufacturers. So in industry parlance, they aren't even called automobile companies or automobile brands. They're just called OEMs, and all this Volkswagen, Renault, Toyota, all these. And it's exactly what you said. Is they're just assembly. They don't manufacture the little bits themselves. That's fascinating. So your output, I'm guessing, does it go to the company directly or to?
Yeah, it goes to the guy. It goes to the OE directly. So you have to work closely with the OE. We call them OE. So the OE. Customer, with the automotive company, you have to work with them. OE, yeah. And there are two dimensions. One is the part has to be of the right quality. And so for the longest time, the automobile industry was headquartered in America. And they had this thing called scientific management. Okay, so they applied all kinds of mathematical and statistical tools to this discipline, production, and tried to control it. And they sort of figured out that every lot of maybe 100,000 pieces would purely by chance have 100 pieces defective. Purely by chance. So they said that this is the allowed defectives, and so they had very nice statistical ways of so you'd send a lot of 10,000 pieces, then they would take a sample of 5 pieces, and out of those 5 pieces, if even one was defective, then you took another sample of another 25 pieces, and if you found another defective in that, the entire lot was rejected, because the probability of there being more than 5 or like 100 parts per million or whatever it is, the sampling would show up that thing. So these are basically statistical methods for eliminating or minimizing quality issue. And the Japanese turned this around on their head. So Japanese people, legendary, they went for zero defect. They said not a single defective was possible. And Americans, for the life of them, couldn't understand why. And the Japanese, what they did was they engineered their process in such a way that even in the most extreme conditions, the process would not yield a defective piece. So they went into process control more than the product control. I
thought it was like changing the definition by saying you may be flawed, but you're still worthy.
That's the American way. That's the American way, right?
Yeah.
Apologies to all rednecks.
No, actually, Japanese have this very nice philosophy, right? Like there are wabi-sabi or kintsugi.
Oh, that's very nice.
Like
That. I read about that recently, that wabi-sabi is very nice.
Yeah.
So a little bit of imperfection is required in life. That's what they say.
Kintsugi is basically where if something breaks, you put it back together with a bit of gold. And so if it breaks again, you again put it back with a bit of gold. So the flaws are actually what make you great and stuff like that. So
amazing.
Some of the stuff really is beautiful. I mean, totally. Just Google wabi-sabi and just.
We should do an episode completely on Japanese philosophy and things like that.
Yeah.
And sushi, which we'll now take a break and Chuck will assemble a plate of sushi for us, which is your new movie, right? See you on the other side of the break.
$100. That's all it takes to begin your journey with Bitcoin and Ethereum. No, really. With CoinSwitch, you can start investing in over 100 cryptocurrencies with just 100 rupees. On top of that, there are zero charges for deposits and withdrawals, so you can trade, buy, sell, however and whenever you want. All of this, plus their extremely intuitive interface, makes CoinSwitch the perfect app for beginners in the crypto space. But don't take my word for it. Just download CoinSwitch for free and try it out for yourself. If you'd like more information on cryptocurrencies, tune into A Show About Crypto with me, Rohan Joshi, my new adventure on IVM Podcasts. CoinSwitch, kuch to badlega.
Welcome back to this wide-ranging conversation about engineering. It's wide-ranging because we don't have a specific topic in mind. We just thought, okay, let's do something around Engineers Day, and we are now sharing engineering.
I was just talking about about automobiles and quality and things like that, but that tells you a lot about engineering itself, because engineering solves problems. So that is how the quality problem was solved by the Japanese, and then it was extended and it was widely adopted by all Europeans and Americans and everyone. They started focusing more on that. It made eminently good sense. They didn't figure it out at first, but once they figured it out, they took it to a fine art. And what they do is they record everything, and they keep studying all processes, and they try and find out where possibly something can go wrong and try and fix that before it happens. It's a great philosophy even for life. Okay. If you just sit down and think about where things can go wrong with whatever you're doing,
possibly
a lot of things, or at least some things, you can sniff out in time and head them off. So that's one aspect of engineering. There's another aspect of engineering which I call the Elon Musk school of engineering, where he takes something which is audacious or absurd, and then by application of relentless logic and lots of money, he delivers something which is good. So I'm very conflicted about Elon Musk the person, because he keeps saying the most absurd things. But I've sat in a Tesla, okay, and if Musk made the Tesla, he did for electric vehicles what Steve Jobs did for
computers as a whole,
or computers and phones or something like that. He set standards, okay.
Yeah.
And today we have really good, whatever crappy Chinese phone you have, because there is iPhone, okay.
Yeah.
And that sets the standard. So even your cheapo Chinese phone that I have has to be really good. Otherwise, I'm just going to spend all my money and buy the iPhone instead of the Chinese phone, because there's a certain level of service I expect, below which I will not, I'll just not accept that. So Elon Musk did that for the car industry. And he seems to have done that for the rocket industry also, but I don't know much about that. But
you mean you haven't sat in a rocket?
I haven't sat in a rocket. Yeah. But
I know what you're saying. Yeah, I know what you're saying. Where
Tesla is this
audacious project. Yeah, I mean, and everything else also, right? I mean, you're right. I'm also equally conflicted about Musk as a person, but the vision of his engineering projects, be it Tesla, be it SpaceX, or even be it the other things, be it that the Boring Company, Hyperloop, solar, the solar power project that he has.
Hyperloop is boring. Boring. Okay.
Boring. The Boring Company. The Boring Company. Yeah. So it's interesting that you brought that up, because I wanted to ask you, there's so much change that's happening in the auto industry specifically right now, with say electrics coming into the picture and all that. So how has that changed life for suppliers such as yourself maybe, or others, or is it easy to pivot from one to the other easily?
It is as of now, it is pretty pretty much life as usual, because electric cars are nowhere close to being feasible. Right. For a long time, for maybe in 10 India, years, 20 years, anywhere in the world, even in the US. It's just because it's the way the US is organized, and the way the amount of money people have, and everything. Otherwise, electric vehicles in India, people are, the government is trying to push electric vehicle development and things like that. But there are huge structural problems for the development of electrical vehicles. But it is one technological breakthrough away, right? So the moment somebody figures out a battery configuration that can charge in less than like 30 minutes or 1 hour and give you more than a couple of 100 kilometers and cost you less than whatever, it will change. So automobile industry is one development away from complete annihilation. The conventional
it's actually quite interesting, no? Just the simple battery, if you're able to sort of change it fundamentally, a lot of things would just change on its head.
And yet it hasn't happened, which probably means that it is very, very, very difficult for it to happen, because the platform on which batteries are now, lithium ion, is not really a sustainable platform. It's not, you cannot indefinitely do it. There are all kinds of structural problems. People are experimenting with other battery technologies, but they have their own, they are liquid metal batteries there. So those batteries are okay for static batteries, for static applications. For dynamic for moving applications, there's really nothing else. And the finest mind, because the people who develop the next battery are going to become gazillionaires. Like, they'll make a lot of money. So all the finest minds in this, in this day and age are probably engaged in battery technology.
Or should be.
Or should be. I was about to say, after making people click ads, this is what they definitely should be working on. Another thing, since we're talking about manufacturing and all that, one thing that I've read recently, and I don't know why I end up reading engineering papers and things, is the use of, for example, Tony, you will know where this comes from, is the use of the IoT and monitoring of devices and all that within the factory itself. We think of, in popular culture, IoT we think is a connected bulb or a connected toilet or something like that. But to me, one of the most interesting uses of connected devices is actually in factories for testing whether, or not for testing, for monitoring whether a piece of machinery, how healthy is it, and whether it needs replacement and all that. So even if the process by itself doesn't get modernized, you're still making the same old car in that sense. You're using these new kind of technologies to make the process more efficient, or at least figure out when something's going to break down so that you have less downtime or whatever it is. Any experience with that, Naren, or any thoughts or anything on that?
All the automation, we use a little bit of automation in our factory as well. And all the automation that we do is basically designed around automating repetitive tasks. Okay.
Yeah.
And whatever little intelligence is infused, okay, is to take care of edge cases. Like, so, I place a particular rod on another piece of metal, and the two are supposed to be welded. I put them in a fixture, and the welding rod comes, and because it expects the material to be exactly there. So the welding rod goes exactly there, and it welds that place, and it welds it in a way that that it's always okay. The weld is never defective. But what happens if the rod is slightly undersized? One rod is slightly undersized, the other rod is slightly oversized, and the fixture is slightly loose. And so everything is now at the edge, and the welding rod comes and doesn't find the material that it expects, and it gives a suboptimal weld. This is the level at which most automation is struggling, okay, at least the automation that I know. And I mean, I go in and out of automobile OE companies as well. It's just not my 3-penny operation. It's even big companies. The level of automation and robotics and whatever is laughably basic, okay. But when we are talking about robots in the popular conception in science fiction and all that, you're just talking about autonomous things. The robot comes and has one look and knows what is to be done and just does it and goes away. Like, there are robots which can come and look at you, kill you, and go away, right? It's that level of autonomy. So why can't we have robots which will autonomously build something, make a component, or make a house or something like that? And that requires a great deal of development in. So we have a lot of progress in artificial intelligence and machine learning and things like that on the computer side, because computers are very easy to program. There is no mechanical dimension to it. It's entirely electronic. So testing and perfection is, it's just a matter of where it's not destructive. So you can just do it on your laptop or desktop, run the simulations millions of times, and then come out with something which is really good. The same level of perfection doesn't translate to electromechanical physical stuff. So that's the next challenge. So when that happens, so one of the things that I really have great hopes for, actually one of the biggest problems in the world, okay, we are reasonably, or not really, we are entirely sufficient as a race. We are entirely sufficient for food. Like I think after the First World War was the last war which was fought basically for food. After that, there has been no war which has been fought basically for food. And so where was I going with this? Yeah. So food is basically taken care of.
Yeah.
What is not taken care of is shelter. So an overwhelming number of people live in very, very, very makeshift and basic, like almost all the poor countries in the world. The main problem is squalid, slum, poor plumbing facilities, drainage, bad health outcomes, bad education outcomes, things like that. All of it can be traced down to housing. And the conventional housing, okay, the whole industry and everything is optimized for money. So so every time somebody becomes rich, they want to store their money in real estate, becomes the storage. So housing is always out of the grasp of ordinary people. And there are efforts to automate the house making process. So there are people who have made these enormous 3D printers. So you guys are familiar with 3D printers, right? You can make little plastic parts on them. So I've seen videos where, this whole thing is 3D printing setup is configured, except with concrete, with a cement concrete mix instead of the plastic. And it can actually print houses.
Yeah, I think they're experimenting with this in Dubai or something.
Yeah, in Dubai. Dubai is a big leader in this, but there are other countries which are also doing this.
Tony,
obviously.
No, I was just saying prefab, is that the same thing?
Yeah. So prefab is slightly different. So prefab is they sort of fabricate the walls, windows, stuff like that, segments in factories, which can be done very efficiently, and then go to the site and just assemble it. And basically you have a house ready in a matter of days. And this works for, or this is supposed to work for mass housing projects. So if you have, let us say, a small little hutment or township or something like that, which you really want to clean up. So the conventional way of doing it is you get all the hutment dwellers to shift to another place while you construct this, and then you give it back to them. And most of them, they don't want to do that because they don't trust they don't trust the people who moved them out to give them the place back because they have nowhere else to go.
Is this a Dharavi issue?
It's an issue everywhere. So that's why in Bombay they have this they have something known as an SRA, slum rehabilitation. They have an
authority.
Elaborate sort of administrative way of method for identify who's been staying, what they'll get. They give them some kind of a certificate, and once they get that and they are dehoused, they are sure to be rehoused when this thing comes up, and they're paid a rent till such time that there's some all this thing makes SRA housing very expensive on the economy.
Wait, how
and this prefab housing is a lot cheaper. You can just
prefab,
10 trucks can arrive and make 100 houses, and 100 people have been rehoused, and they can just.
It's interesting. There's just so many engineering solutions to all these problems.
Yeah. So that, and so the promise with 3D printing is that is even more. So in prefab housing is also very, very feasible. You just need to put a lot of prefab factories all over. So if you want to solve the housing problem in Bombay, you can't have your prefab factory in Delhi. You need to have one prefab factory close to Bombay. So you'll have to have multiple prefab factories everywhere.
Yeah, it's interesting. Are these problems even discussed in engineering colleges and things like that?
I don't know. I mean, engineering college, at least what little I know, the level of instruction is very, very, very. I can't blame them because they're very young students, undergrad at least.
Yeah.
And they have to take in when I last counted some 50 or 60 different subjects that an engineer studies.
Yeah, and not all of it is really required, right? I read this stat that around 91% or something of that, so it's 85% upwards of all engineering grads have actually considered not qualified, but they don't have the required skills to actually work in engineering, be it technical skills or be it communication skills or whatever the case may be.
And that said, in my opinion and in my experience, I'm a practicing engineer. A lot of those skills are literally acquirable in days of training. You could train people for a week and they would be up to speed with a pretty good engineer if in that particular field. So specialized things, let's say hydraulics. Okay, so in factories, hydraulics are used for moving machine parts and things like that. And it has some laws, it has some rules, it has some equipment, some valves, some things. And if I were to show you a hydraulic machine, you would be intimidated. You wouldn't even think of, you wouldn't know whether to touch something and something will just blow up. So if you basically just took 1 day or 2 days of training, you'd be able to repair all of them.
So does engineering college act as a filter for people who have made it through an entrance, or is there something intrinsic in the 4 years of?
So at least, I mean, all of us have gone through, all three of us have gone through engineering, and to a great extent, it is basically is just a filtration qualifying process. The professors teach you, they come and share things with you, but you are not in any position to understand any of it because all of engineering by definition has a real world dimension which you don't know about. You haven't seen the inside of a factory. You have no idea what's happening.
Yeah. So 90% of an engineering college is inside a classroom, right? Which is
correct.
Sort of
but my question was, if you hire a non-engineer would they pick it up as
They
in the
do.
same
Yeah.
time
So
as-
in my
My guess is
experience,
they
they do. I find that they do very well, and it's very easy. And today with YouTube and I'm exceptionally impressed with the quality of instruction available on YouTube, especially on practical matters, because you have the video dimensions. Actually, tell you, when I was talking to you about hydraulics, I actually used a few YouTube videos to train my people
Amazing.
to maintain, and they are all in Hindi. So they're videos made by technicians who explain in Hindi how a particular thing works, and they do a fairly good job of explaining the engineering behind it also.
Right.
So, if you wanted to calculate what horsepower of motor you need, if you wanted to lift a 5-ton weight in your factory, okay, hydraulically. So how do you calculate the horsepower? He'll explain to you in 15 minutes. And I needed a 1-semester course in hydraulics to understand that back in the day. Yeah. Literally 15 minutes. And everyone in my factory knows it now. They know how to calculate. You tell them, they'll calculate it.
Yeah. Amazing. So till now we've been talking about engineering in the classical sense, right? Which is actually getting your hands dirty, going to factory and all that. But the definition of engineering in some ways has changed over the last 20 years. In many ways, the advent of computers and all that in so many dimensions, right? Today, when you see headlines like engineers are commanding a premium for salaries for product jobs in Bangalore and all that, they're talking about the more AI, ML, that sort of engineering. And also it has an impact in terms of jobs, right? Just to add to something that Tony said, it does act as a filtration process, but mostly for, say, at least during our time, I don't know what the situation is right now, at least IT companies who wanted engineers en masse so that they could code, etc. And for the IT companies also, it is a great deal, and it acted as a great filter for them as well. Here are kids who are reasonably smart, put them through a 2-month boot camp in coding and database, whatever, and they will start churning out code pretty efficiently. Kind of like works for them. So like, I find it fascinating how the definition of engineering itself has sort of changed from that engine part of engineers to the original etymology of engineer is actually the Latin root for ingenious. And engine comes from there. So I find that kind of interesting. I don't have like a question or anything over here, but I just find it sort of fascinating to see how engineering itself
I can
sort of
relate
evolved.
to this. So a lot of my friends are in the so of all streams. Okay, we didn't have computer science back in our time, so most of us mechanical engineers and electronics engineers and electrical engineers. They all went to the US and they all became computer engineers because that was just happened to be the time that industry was really coming up. And the thing that happened was it became incredibly complicated incredibly quickly. So it just like, and now it is the level of complexity have become so high that you engineers are forced to specialize in very, very narrow fields. So someone who specializes in search in Google will be completely clueless about everything that's happening, let's say, in cryptocurrency. And someone who is specialized in cryptocurrency would know nothing about social media, whatever software platform. And they are so my son, like he's in this field, so I know secondhand from him how crazily complex and sophisticated these fields are. And
in some senses it speaks to what you said before, right? Like till the World War I time, like food was important. Now we've reached a point where everything is in plenty, right? So monetizing opportunities actually no longer arise from like physical problems that need to be solved. You have like basically like the upper end of
self-actualization. You're solving that sort of thing.
Therefore, there's a lot of money in like even getting people to click on ads. So why not?
Actually, I in many ways, I mean, for all that I heap scorn upon the MBA education, the function of management itself has become more complex and more nuanced by several orders of magnitude because of technology. Like you, especially you, Chuck, you've seen the ad agency business through all its generations, right? So through the conventional to the digital, and while the fundamental principle remains the same, you want people to see your ad and be influenced by it. The ways of, I mean, you cannot afford to be ignorant any longer of what's happening.
You can't. I mean, I mean, that rings out to me, and I think that's a
which is again sort of fascinating, because the entire transformation in ad industry has come from engineers, right? Like basically Facebook and Google has completely changed advertising, which is,
I think that's a completely different. I think we should do a separate episode on just that, how Facebook, Google, and now increasingly Amazon have changed the advertising landscape completely. And Naren, don't know if you know this stat, out of every $100 of advertising spent in the US, 70 of it goes to one of these three companies, Amazon, Google, and Facebook. So it's staggering. I think it's a completely different episode. But okay, that's but I think like the role of engineers, there's so much more to do, right? So many problems to solve, from the battery problems that you were talking about to new spaces, right? The pandemic has shown that there are so many problems still to be solved. Stuff in the intersection of biology and technology. I think
that's something we haven't touched on, but that's another frontier. So when a few years ago, someone was talking to me about something called exoskeleton. So it's like that Iron Man suit, and apparently, it is a thing. So it's for people who can't move on their own accord and things like that.
And there are so many other spaces that are coming up around the world, either because of one of these imperatives or politically. Like, for example, renewable energy right now around the world. Right now, whether it's going to be a success or not, we don't know. The fact of the matter is, everybody from corporate boards to governments are like pouring tons of money into it. So, for example, a solar engineer and a solar installation engineer are supposed to be very lucrative careers in the future. Similarly, anybody who is trying to make meat alternatives, for example, not sure whether engineering is involved as much over there, but eventually it will be once it needs to be mass manufactured. There's lots of spaces in the future. I think a great thing to do for anyone listening and interested is just to dig out one of these jobs of the future report. Like a lot of companies have one, Deloitte has one, CTS had one, I remember, and many of them point to jobs that spaces that are so nascent right now that if you just get into them, especially anything in the intersection of healthcare and technology, they're going to be very, very promising in the future. I think there are going to be departments in engineering colleges that we studied at, which we can't even envisage right now. And some might become completely obsolete.
True.
We end on an optimistic sort of note.
No, but as much as we say like things are moving to the niche, it also means that Naren, you've straddled several generations, right? So once you have the basic sort of problem solving mentality, then adapting to a newer thing is not all that good. Because technically engineering is not research, right? You don't need to have spent years together of deep knowledge into it. It's more about applying certain principles and figuring things out.
And so there is a difference between engineering and Jugaad. Jugaad is very interesting and required. And so Jugaad is when you find inexpensive and immediate and temporary solutions to problems. Engineering is about analyzing, knowing those problems well, anticipating them, and either fixing them permanently or setting up so that they never occur at any time at all. So you do need to understand scientific principles and your sciences really well in order to be an engineer. That's why we have this Engineers Day, because it's named after, it's in memory of Vishveshwaraya, who's born on 15th of September. And he was one of the early sort of appliers of scientific principles. He was basically a civil engineer, and he was famous for system of dams and weirs and things like that, and flood control. I think what made him famous was flood control for Hyderabad. Hyderabad is on a river which gets inundated pretty sort of mercurially. All of a sudden, suddenly it will flood, and there'll be floods all over the place in a place which is almost always dry. And he set up a system which insulated that entire city from these kind of floods. And so I have an anecdote here to, which is not Vishweshwaraya anecdote, but it's an anecdote about engineers versus, non-engineers. So it's apocryphal, so I don't know if it's true, but the anecdote, such as it is, here is the anecdote. In around the turn of the century, the king of Gwalior, the Scindia of Gwalior, wanted a bridge built across a river called the Betwa. So the Betwa sort of cuts Gwalior into two, and people had to cross using boats. So king thought having a bridge across this river would be awesome. And so he, it's a bridge. It's not a very huge river. And so they built a bridge. And so before building the bridge, they had a groundbreaking ceremony. They got pandits were called. They did a puja. And the first monsoon after that, the river in spate washed the bridge away. So the king was very disappointed. And he called a meeting of his council of ministers. And they came to the conclusion that the puja that was done was not the correct puja. So the spirits were not propitiated, the time was not right. Pandits were summoned from Haridwar, really learned people. They did the whole thing. They had a huge, home, and everything was done. They built the bridge again. And the next monsoon, again, it was washed out. The third time, the Maharaja just engaged a British engineering company who built it, and the bridge is standing to this day.
Wow.
More than 100 years later. So engineering
what puja did they use?
That's something that I think is the sly British people, they'll never tell you about those things. Real important stuff. They just write about their engineering stuff. Yeah, they'll never
I think in
tell
the post-independence, dams were one of the big engineering things. They were called the temples of modern India.
Temples of modern India. Yeah.
And also, just engineering colleges in general were set up very early on, right? Warangal was the first REC. I think it was set up in 1958 or something. So,
if you look at the spirit of the time, this was pretty, it was pretty advanced thinking. I mean, India was a very superstition-ridden. Yeah, so it introduced a lot of scientific temper.
There are lots of stories related to dams, like you said, Tony, and these are all sluice of life. I never thought I would get the opportunity to make that. I think we should. I think we have spoken about engineering.
Yeah.
So I think we should wrap things up. Yes. Gentlemen, what do you think? It's been fun. It's been interesting. Yeah. We had no agenda with this episode. I think we have covered everything from.
We just wanted to ramble on and on about engineers and
about engineers. Celebrate engineers, engineering, scientific mindset, analytical. What do we say during MBA interviews? Analytical skills. We have analytical skills. So
problem solving.
So here's to those analytical skills and us using ingenuity to solve more than clicking ads. So Naren, you know what to do.
Stay safe, stay well engineered, and stay simplified.
Fair enough.
See you next week.
And see you next week. And happy Engineers Day on the 15th, everybody.
Hey, it's been another great week on the IVM Podcast Network. Postcards from Nowhere completes its 100th episode. Utsav speaks with Chuck, the host of Getting Meta, Origin of Things, Simblified, amongst others, about slow travel, the evolution of Postcards from Nowhere, and what drives them to travel. Tune in and discover the new manifesto of the show and get a glimpse of what's in store for the coming weeks. On The Habit Coach, Ashton talks about the art of focusing with our eyes and how it's connected with our daily activities. On Echoes of India, Anirudh brings back to life the history of South Asia through his extensively researched narratives. And on Simblified, our four hosts, Chuck, Naren, Srikeit, and Tony, attempt to deconstruct these universal birthday rituals on the occasion of Chuck's birthday. Do follow us on social media. We're IVM Podcast on Twitter, Facebook, Instagram, and LinkedIn. And remember, if you're enjoying this show or any of our other shows for that matter, please do tell a friend. And finally, we would like to thank our sponsors this week on the network, Fiat Cred, Bank of Baroda, Quarter, CoinSwitch, Kuber, and Intuit India. Thank you so much for making this possible.
Namaste, this is Cyrus Brocha. I am part of the government cancel culture program to remove rubbish off all the different streams available. So what we have is all the collected rubbish we put together on our show. It's called Cyrus Says. It's on IVM Podcast. You have to watch it and listen to it. It's on our app. It's on our website. It's on the YouTube channel. It's on Facebook. There are many different ways. Don't bother me and ask me how. You have to find out. We talk to different personalities. Many of them are known. Some are just people we meet downstairs and invite them up for chai. But the point is, it's fun and it's very therapeutic. So please join in and listen to Cyrus Says.